Welcome to another session of Ebenezer Gate coaching classes. This is a problem that appeared in GATE 2014. It is a numerical aptitude type problem for 1 mark. The figure shows a half-wave rectifier. The diode D is ideal. The average steady-state current through the diode is approximately dash. Now, if you look at the circuit carefully, the input is a sinusoidal signal, and initially the capacitor will be charged to the peak, that is 10 volt. And after that, the capacitor, let me draw the input signal in dotted lines. So this is the input signal. Once the capacitor input voltage decreases, the capacitor does not discharge so fast. So the diode remains reverse biased. And once the capacitor voltage falls below the input voltage, the capacitor again charges. So this repeats. Now, how to find out this? So the diode current conducts only during this period. So this, how do you find out the average steady state current? So the average steady state current is average steady state current is actually the charging of the capacitor divided by one complete time period. So every one time period, the capacitor gets charged to a small amount. So this, so you should know how much current is, how much voltage is decreasing during the discharge. So how do you find out that? Or to find out that, so the voltage initially of the capacitor will be 10 volt. Then the capacitor will discharge. Since the diode is reverse biased, so the capacitor will discharge via the resistance. The current through the capacitor will be IC will be 10 divided by R, 10 by 100 is equal to 0.1 amps. Now this 0.1 amps discharges the capacitor. So this is, what is the voltage across the capacitor? 1 by C integral I dt. So this is 1 by 4 into 10 power minus 3 integral 0.1 dt. And this is actually the entire, is almost equivalent to, this is almost equivalent to capital T, which is the time period of the input signal. So this is, can be written as 0.1 T by 4 into 10 power minus 3, and it will get discharged for a time period capital T. So the voltage decrease in voltage, delta Vc will be 1 by 4 into 10 power minus 3 into point I is actually 0.1 capital T, 0.1 into capital T. So this is 0.1 into T capital T is now 1 by F is 50 divided by 4 into 10 power minus 3. So 4 into 50 is 200. 200 into 10 power minus 3 is 0.2. So 0.1 by 0.2, that is 1 by 2. Delta VC is 1 by 2 volts. Now, whatever capacitor voltage has decreased, when the input rises above this decrease, that is, initially the capacitor voltage was 10 volt. Now it has come down to VC has become 10 minus half or 9.5. Now it has to again charge to reach 10. Now again, during that time, the diode will be conducting and charging the capacitor. So it has to increase by 1 by 2. So what is the charge in the capacitor? Q delta Q will be delta VC into capacitance. So that is capacitance is 4 into 10 power minus 3 into 0.5, which is 2 into 10 power minus 3 coulomb. And the average, this is the change in charge. So average current through the diode, average current through diode is going to be delta Q by T. Because every cycle this change in delta Q will happen. This divided by T is going to be the average current. So this is 2 into 10 power minus 3 10 power minus 3 divided by 1 by 50. So the average current through the diode, which is going to charge the capacitors. So ID is going to be 2 into 10 power minus 3 by 1 by 50, or 2 into 10 power minus 3 into 50 equal to 0.1 amps. This is the answer to the problem. So in amperes, it is going to be 0.1. Thank you. God bless you.